Our L2000 laser system began development in 2013 and was available on the market in late 2014. We developed this as an add-on option that could be attached to not only new machines but certain older generations of our L series machines. We designed this to have as little effect on the machine's capability as possible. The L2000 is available on all of our L series machines from 12 millimeters to 38 millimeter. Also on our A20 Type 7 machine, and beyond that, our Miyano BNA 42mm GTY machine. Some of the major benefits of having a laser in a multi-axis machine is you can cut just about any shape, get minimal burrs, it's faster than EDM machining, you get conventional machining and laser machining on one platform. And you can do laser cutting and or welding with a single head. With the use of a bar feed, you can run up to 12-foot long bars, tubing, or solid stock. This will allow you to get continuous, unattended operation out of your machine. With the multi-axis machine, you'll be able to complete multiple operations in a single setup and attain reduced handling, improved process control, and increased throughput. You'll also be able to do any recutting, brushing, honing, reaming for any burr removal that might be needed. We utilize the IPG Photonics lasers in our system. They are the leading provider of lasers in the world. The laser is 100% supported in the USA. We have multiple power levels available from 100 kilowatts all the way up to 4,500 kilowatts, all air-cooled. Our system has an internal pulse generator with endless parameter possibilities. We've included an air conditioning unit built into the cabinet for temperature control. We can connect up to 3 gas supply lines. We have integrated our system so well into our machine that we can program everything that's needed from the part program. We have programmable modes with pulse mode, burst, continuous wave, or quasi-continuous wave. We can create special macros from the part program, send it to the laser. We also have programmable gas or air pressure and the type and selection from the program. And to top that off, we have a programmable collimator to fine adjust the focus position. You can tell the focus where to be on the part from your part program. So you might ask, why would we want to have a laser on a Swiss turn machine? What we found was many of our customers were doing parts that had to go to a secondary operation to have some laser cuts done, some of them very simple, just a turn angle or so forth. When that happened, they had secondary setups and queue time and all of this. Now we've tied it all into one machine, so you're in one process, you get a complete part straight off the machine. The typical components of a traditional laser machine has a laser oscillator or power unit feeding the fiber down to the laser cutting head, which is also being supplied assist gas of some type, depending on the material you're cutting, going through the nozzle around the beam. The L2000 system has a control cabinet located behind the machine, which encapsulates the power unit. The power unit has the fiber, which runs through conduit up into the machine, into the laser head, which is mounted from the gang plate. We have mounted a touchscreen PC monitor above the machine control, which will display the settings being sent to the laser, and also has the software for the camera, which you get the camera view that is looking out through the nozzle. The camera view is most helpful during setup or replacement of the nozzle. The nozzle, which helps direct the assist gas around the beam as the beam is cutting into the material. The laser controlling software is called IPG Link. This is where the cutting parameters are displayed when they're sent to the laser unit. The settings needed for the laser to work is going to be setting the mode, the pulse width, the size of the beam shots, the frequency, how many beam shots per millisecond, the percentage of power of the unit that you are using, the gas type you're using, inert, oxygen, or air. You will also set the pressure for any air, gas, whether it's inert or oxygen. Here we have the IPG Link screen, which will be displayed up on the PC monitor. Here you will see the commands have been sent from the part program to the system to show you what is happening with the laser system at any given moment. You can also manually enter information here to do a kind of a test before you run through the program to see if everything will be accepted by the system. Displayed here are the available pressures and the program pressures that might have been sent from the part program to the laser system. The status box is a list of the last 4 commands that were executed by the laser system. In the lower left corner, there are a few buttons that you could push. The laser status brings up an additional box showing the status of different functions of the system.
The I/O button also brings up another box which shows what inputs and outputs are being executed. Then there is the emission button where you could turn emission on and off, and the ready fault tells you if it's in the ready state or fault state or stop. And then the off and on button at the bottom. In the main display box, it will show you any faults or errors that might occur during the system, giving you some short explanation as to what might have gone wrong. When pushing the laser status button, we'll pop up this box here, which shows the status of different functions inside the system. Here you have the box that will pop up when pushing the I/O display button. Our system contains a temperature and humidity sensor to constantly monitor the environment of the laser head. The current temperature and humidity values are displayed in the laser status window. We are using dprint commands to communicate with the laser system from our part program. Here you see the format of many of those commands. Turning emission on or off. C position would be collimator position or the focus position. QCW on or off if you have a model with that mode. The gas type you would like to use, pressure required, the mode, pulse width, frequency, and power percentage. After all those are sent, you will turn emission on, which will activate all of those settings. Once you have completed any cutting, welding, or etching that you needed with the laser, you will deactivate all the settings by giving it the simple command, all off. There are a few additional commands that you may use in the system at times. At the bottom, you will see the M codes used. These are M codes that turn the beam on and off. M260 turns it on when you're ready to cut and in position already. M261 when you have finished the cut and shut it off immediately. Our system has the ability to laser weld as well as laser cut or laser etch. With the welding, there's no adjustments that need to be made that cannot be made from the part program. The biggest challenges you're going to reach are going to be, we're going to weld two parts together. Where are the two parts going to come from? One might be bar stock, another one might be bowl fed into a loader of the machine into the subspindle. And then we will come over and press them together lightly, touch them end to end, and weld them together. Here you see where when the upper left, when they were touched together, then they run through the weld. The bottom right is what the weld looked like when it was completed. Very often the parts that we're presented with create some unique challenges. We do have to cut parts that are as small as 0.5 millimeter in diameter. So to do this, in order to have the support that we need out at the laser nozzle where the cutting is happening, we're using extremely extended nose guide bushings and collets, pick-off collets also, in order to support it. In the picture here, you can see I was cutting a 1 millimeter diameter stock, so I had an extended nose guide bushing and an extended nose pick-off collet, and had to get the nozzle right in between the two in order to work. Now to show you some sample parts. Here's a shaft part with the dovetail-like cuts along the shaft to make it flexible. Next, we have a small titanium part that was out of solid stock, so we had to drill, bore, ID groove, turn the OD, do the laser cuts. And this one particular part we actually cut off with the laser also because of the flimsiness of the part. Often we're running very small tube out of different types of material with hole patterns in it, helical patterns, spaced out patterns. We generate the holes just like we would with an end mill. There were many medical parts that were already being laser cut or off the machine. So what we were able to do was take these tubes, put them in the machine, and do all these fancy little cuts that they needed, little windows and bendable tabs and so forth that come out dross-free, finished part right off the machine. We've done multiple materials. So you can see Inconel here, copper, a little more challenging. 1740, saw in a few of the samples I already showed you, many different shapes. 303, 304, 316 stainless. Here's a 303 part with 1,800 8,000 diameter holes in it. Now this was from solid stock that we had to drill, bore, because it's flat bottom inside there. It took about 11 minutes altogether because each one of those holes was move, turn on the beam, generate the hole. Here we have a stent-like part being cut. First view from the rear of the machine showing you how the laser is approaching the part. And then we will switch to the front view where you'll see more of the stent being cut, and you can kind of make out more of the shapes of what's happening inside of the machine during this cut. As a note, I'd just like to point out that we're running dry just for the video. Normally we would have not only high pressure coolant running, but coolant through the bar stock at the same time. When we bring the machine to machine shows, we have to show the capability of the machine. So we do many different shapes. A lot of the shapes that we find on the customer's prints that we apply with different sizes onto a part so people can see that we can do these. And here you can see hexalobes and trilobes and hexes. Another part here where you can see it has like teeth on the face, has an OD thread, sort of a puzzle type cut and a stent cut. This part here was very unique. Because of all the shape that was cut in it, it was actually able to expand the part. Now we have a multi-part in one program with laser cutting and laser welding. This was from solid 1.25 inch stainless steel, where it was drilled and bored and turned and then pressed together and welded, and then did the second part, same thing, and then the third part, pressed the third part into the second part and welded it back together. So it came out, ejected out of the machine in one solid piece. Here we have a laser cut flexible bone screw. It has a bone thread on both ends, and in the middle on the shaft, which was turned down, is a laser cut. You can see on the left picture where it was the flex that it had to it. As I had mentioned earlier, there are virtually endless possibilities of the cuts that you can do with the laser. Here are some somewhat common cuts that we see in parts and the cycle time that it took for just the laser full portion of the cut. Thank you for joining us, and I hope this has given you some more insight and information on the laser that we offer and how it can be used for some of the parts that you see come across your desk. If you have any questions, see your local dealer. Now enjoy another video showing more details and videos of our laser L2000 system. Please submit any questions and we will get to them at the end. Thank you.
The Marubeni Citizen SYNCOM laser system L2000 is a 10-micron fiber optic system offering high-precision, high-speed laser cutting. Incorporating the L2000 on a SYNCOM Swiss-style lathe provides the capability of combining conventional Swiss machining and laser cutting on a single machine platform, reducing part handling and ensuring improved part accuracies. The L2000 utilizes the IPG Photonics 400-watt laser unit. IPG is the world leader in providing fiber optic lasers and is fully supported in the US. Additional power units are available that address specific application requirements. One option is a QCW, quasi-continuous wave 300-watt system that can provide power bursts to 3 kilowatts for extra power when needed. The laser head assembly mounts on the gang tool slide of the SYNCOM machine. The movements are programmed in the part program of the machine control. The unit has the unique capability of also mounting on the B-axis tool position, allowing for laser cutting at various angles for components that require angular laser cut features. The laser head assembly is liquid tight, so it's capable of operating while high-pressure coolant is flooding the workpiece during the machining process. Internal air pressure protects the lens and internal components. High-pressure coolant that is used during the cutting process also feeds coolant through the tubing material in the auto-loading bar feed system. This provides a flushing of dross or chips that are created during the laser cutting process. An integrated custom-designed CCD camera for optical viewing and alignment is included for XY beam alignment to the nozzle. The live camera is visible on the included touch monitor. This greatly reduces setup time. The L2000 is completely interfaced to the SYNCOM control. Cutting path and offsets are fully controlled and edited in the machine control. Laser power and gas type can be selected from the part program. One of the unique features of the L2000 is that it's a modular system and not designed for a specific model SYNCOM machine. The system can also be retrofitted to some older model SYNCOM machines. For additional information, please contact Marubeni Citizen SYNCOM at marusit.com or your local SYNCOM distributor.